Hello everyone, I'm Kinsarin from Karnal Institute of Technology and Sciences. So as part of my final year project, I'm working on a project called diabetes prediction using machine learning techniques. So this is the agenda of the project. So we're going to see how this project is implemented. So this is an introduction. So if you see, currently there are 537 million people in the world suffering with diabetes disease. So this is a chronic disorder where the pancreas are not sufficient enough to produce the required amount of insulin inside the body. So there are two broad classifications under this disease. There are type 1 and type 2 disease. So majority of the cases that we see today are coming under type 2 category of diabetes, so which is mainly due to the lifestyle habits and bad food habits. So type 1 diabetes is mainly it mainly occurs due to hereditary problems and a genes problem. And coming to the objective of this project, so the main objective of this project is to include some machine learning algorithms like logistic regression, random forest classifier, distant tree classifier, and support vector machine. And using these algorithms, will be predicting if the person is prone to have diabetes disease or not. So there are two phases in the development of this process. So the first one is the development of code and design of the project, and second one is the deployment of a project into the cloud. Now coming to the literature survey. So this is the problem statement I have already told. And literature survey, so these are some of the papers that are related to our project. So most of the papers are showing good accuracy score, but they are not, the machine learning models are not interpretable, and most of the machine learning models are just like standalone applications running on the local machines and not deployed onto the cloud. So these are the two things that we are going to overcome in this project. Now this is the proposed system. So we're going to apply strong machine learning techniques, and we're going to interface them with a web application, so the users can easily use the application in predicting if the person has diabetes disease or not. Now this is the use case diagram, and here we can see there are two actors. That is, first one is the user, and second one is the developer. And in between them, we're going to use a web application to interact with the trained machine learning model. And to do that, we're going to employ a framework called Flask framework. So this is going to act as an interface between the web application and the machine learning model. So we're also going to have a user database where we're going to store the records, the results of the users that have those who have used the application. So this is the sample use case diagram of the project. Now this is the proposed architecture. So as usually, we're going to use a dataset that contains several attributes that are related to diabetes, and after the dataset comes in a raw format. So we're going to pre-process the data and apply the machine learning algorithms to it. So once the performance is satisfactory, so we're going to select the best performing model out of the machine learning models, and using the Flask framework, we're going to integrate that with the web application. So this is the proposed architecture and workflow. Now this is an introduction to the dataset. So we're going to work with the attributes like age of the person, gender, family diabetes history, the blood pressure, whether the person is physically active or not, BMI, smoking, alcohol, sleep, sound sleep, and regular medicine intake, and junk food, and stress, and pregnancies, and frequency of the urination are going to be the dependent variables attributes. And diabetic is that dependent attribute that is to be predicted. So they are the attributes that are independent of the output. Now coming to the data pre-processing. So we're going to work with some steps like label encoding, where the categorical variables are encoded into numerical forms. That is the process done under label encoding. Now coming to the outliers. So we're going to calculate the z-score for each data point, and if the z-score is lying within 3, and we're going to include that record in the dataset. Otherwise we're going to delete that from the dataset. So we're going to calculate z-score using the formula like x is the data point here, and it is subtracted from the mean divided by the standard deviation. So using the z-score, we're going to deal with the outliers in the dataset. Now coming to the feature engineering. So we're going to build a Pearson's correlation matrix, which helps us to identify the association between two attributes, like if the correlation between the two attributes is high or not. So only the attributes which don't have the high correlation between the dependent attributes, we're going to include those attributes, and the attributes that having a satisfactory correlation value with the independent values, and those attributes we're going to include in the dataset. Now this is the Pearson's correlation matrix. So here we can see all the correlation values for between each two attributes. So that's it. So here we can see that no two independent attributes are having a high correlation. So that means that they are not exhibiting any duplicacy. Now coming to the algorithms training. So we're going to split the dataset into two, like using a stratified shuffle split, and to ensure that equal proportions of two categories are divided in the two parts of the data set, that is training set and testing set. So there are the algorithms that are going to be implemented. So logistic regression, so it works like just like a linear regression, just by calculating the probability of the event that is going to occur. So instead of a linear curve, we're going to have a curve with a threshold value split at in between. So above the if the value data point lies above the threshold value, then it's going to be classified as a class A, and if it is below the point, then it is going to be classified as another class. So this is support vector machine, where we are going to have a hyperplane. So the regions on the either side of the hyperplane are going to be the classes. So the main objective of this algorithm is to maximize the margin so that no two data points like collide with each other. Now coming to the decision tree classifier, this is the tree based algorithm. So the above two algorithms are distance based algorithms, and this is the tree based algorithm where the nodes represents the attributes. So here the feature we are going to select, that is based on two factors, that is information gain and entropy. So highest information gain and lowest entropy feature, that is the feature that we are going to select at first. Now coming to the random forest classifier, this is similar to the decision tree, but we are going to rely on more than one decision tree, and the decision of more trees will be considered as majority voting, and final result is obtained. So these are the four algorithms that we are going to use. Now these are the sample web page interface that we have developed for the diabetes prediction. So coming to the model interpretability, like most of the cases machine learning models are not interpretable, like we are not able to recognize the factor that is actually contributing to the presence or absence of the disease. So using model interpretability, using the LIME package, we are going to actually we are able to implement this concept where the user is notified with the factor that is contributing a lot to the disease. So here we can see if a random sample is showing the factor as age that is greater than 55, and that has contributed to the presence of diabetes. This is a sample for the random person, and using the predict proba function, we are going to predict the probability instead of just classifying the record. So the highest accuracy that we have achieved is 96.84, that is for the random forest algorithm. And coming to the learning curves, so here we can see how the algorithm is trained. So on the dotted line, it indicates the train score. As the testing size increases, the train score for the logistic regression curve is not stable. Here we can see. Now same in the case of support vector machine also. Now coming to the decision tree classifier, as the training set increases, the train score also is linear with the parallel to the training set size. So this is why the algorithms are performing better. There is the tree based algorithms like decision tree classifier and random forest classifier are performing better. And coming to the conclusions, for the scope of this project is to analyze the real-time generated data. Like if the user enters some data, we are going to make use of that data in order to update the training data, so that our application will not be outdated in the further future. So that are the several enhancement that are yet to be done on this project. So on the healthcare sector also, we need to find out the correct attributes that are contributing to the disease. Now we are going to see the code for this. This is the code for the diabetes prediction. So we have imported all the modules that are required. Pandas is used for the data preprocessing, and NumPy for the dynamic calculation of array values, and this is for the algorithms. From the sklearn package, we have imported the algorithms, and that's it. To plot the graphs, we have matplotlib, and here we can see we have a glance of the dataset here. These are the attributes that are being considered. Now if we see the info, so here we can see the data type of these columns are objects, not numerical, so we're going to change them as well. And here we can see the shape of the dataset is we have 952 records in the dataset and 18 attributes in total. Now here we can see we have analyzed some of the statistics, like here we can see the data is not in numerical form, it is in textual form. So we have done the same thing for all the attributes, and we have replaced the categorical text value into the numerical value. Fine. So we have done for all the attributes. Now we have some improper values also in the dataset, like we have instead of having 0 as value, we have in the raw dataset we have something like O, so we have deleted such kind of values manually. And here we can see we have converted the object type into int using the as type function for the regular medicine attribute. Now using the fill NA method, we're going to fill if the values are missed in any of the cells in the dataset. Okay, so ffill it represents the forward fill. So what is the value that is present in the next cell will be coming into the present cell. Okay, now coming to the outliers, so we have calculated the z score here, the data point minus the mean divided by the standard deviation of the entire attribute. So if the value is greater than 3, then we are going to drop that record. So for each categorical attribute, so we are going to do that outlier handling. And coming to the train test split, so we have used stratified shuffle split, and this is a test size data, that is 0.2, that indicates 20% of the data is for the testing dataset. And so here we are going to give some categorical attributes that are correctly correlated with the dependent attribute. So in this case we have considered family diabetes, so it ensures that in this attribute the two classes of the values are equally distributed. So here we can see on the train set, the family diabetes value counts is 0 and 1, that is 393 and 360, and in the test set 99 and 91. So if you see the ratio, it will be almost similar. So that is the reason we have used the stratified shuffle split. And coming to so here we have dropped the dependent value to train the algorithm. So to train the algorithm, we only need the independent attributes only. So for that purpose we have dropped, and for testing purpose also we only need the independent attribute. So for that purpose we have dropped the dependent attribute from the testing dataset also. And coming to the algorithm, so we have instantiated all the algorithms. So currently we are on the decision tree classifier. So if we just execute this cell, so our model is instantiated with decision tree classifier. So if we train the algorithm, so here we can see the result. And coming to the prediction, so here I have manually written the code for testing the accuracy. So if this is where the predictions come in pred1 variable, and in the and the actual values will be lying in test target. So if the values are equal, then we'll be incrementing count 1, otherwise count 2. And based on those two values we're going to calculate the accuracy. So the correctly classified records is 184 out of 190 records, so leading to the accuracy of 96.84. And this is the using metrics method we can calculate the accuracy without manual code. So that is also showing the same 96.84%. Now coming to the learning curve, so this is the code I have already explained what is the learning curve in the PPT. And coming to the confusion matrix, so we have also built the confusion matrix for the classification results that have been generated. So we can see the precision is 97.9% and specificity is 99.2%. And here we can see we have done the model interpretability using the Lime package. Okay, so here we can see we have used the proper function instead of just predicting the class. So this ensures the result is shown in the percentage rather than just classifying the record as yes or no. So this is the result of. Now coming to the web integration phase, so here we have the folder where all the files are present. So model.py is the Python file where we are training the machine learning model. So this will be generating a pickle file and storing the model in that pickle file, and we are going to use that pickle file here. And using the main.py, we are going to use the Flask framework to route the application. So first thing we're going to route to the index2.html. So this is the page we're going to load first, and in that page we're going to ask the user to enter some values. This is a HTML page, and once the user enters the values, we're going to retrieve the values from the user. Just a minute. And those values are fed into a list and converting that list into an np.array, and using the model we're going to predict the output for those inputs. And after the result is generated, so we're going to redirect the user to another page, index1.html, where the structure is going to remain the same. The change is in the bottom we're going to display the result with the using progress bar. So that is present in index1.html. So we're going to run the same file and see the output. So this is the link where the site has been loaded. So if you just enter the values like age and BMI, for example 23, average sleep 8, and regular medicine consumption, by default it is no, and smoking no, alcohol no, junk food consumption, and let me keep those values same, number of pregnancy 0. Now if we just click predict, so here we can see the risk of diabetes is only 14%. So in this way our machine learning model has been integrated with web application. So soon this project will be deployed into some server to make it available for all the users. So this is about the project, and thanks for watching.